Hey, Jackson.
Hello.
So you on sum and difference yet?
I actually wasn't in class today. I had a doctor appointment. So I already sent you the picture of the homework for tonight, though.
Okay. Let me pull it up here.
But from what it looks like now, some of them are in the interval 0 degrees to 360 degrees.
That's still 2 pi.
Yeah,
Same thing.
that's all the directions say. And then some of them are the 0 to 2 pi.
Yeah, they're both the same because 2 pi is 360 degrees. So we're still solving trig equations, okay? Starting at 1.
Yeah.
Now, I can't see. It looks like we got brackets around both. Is that true?
Yeah.
Well, that is a different interval then. In other words, the interval yesterday, or the last time we met, was 0 to 2 pi, but the parentheses were around 2 pi, which means you didn't have to go all the way up to 360, and that does make a difference. All right, so I assume you want to start at 1 and go from there?
Yeah.
So what's sine x equal?
1/2.
And what's x equal?
Sine inverse 1/2.
Which is?
Hold on, let me draw the triangles real quick. Sine inverse sine 1/2 is 30 degrees.
Okay. That's one spot. There's always at least one more.
And then the other one will be 150 degrees.
Okay.
Cosine x equals 1. Or no, -1. -1.
Okay. Where's that happen?
And then x equals cosine inverse -1.
Okay.
And then so that'll be a 45 degree.
No. In other words, this is a quadrangle. You can't get the quadrangles off of the two triangles. You have to either get them off of your cosine curve, or there's a neat little trick you can do with the unit circle that I would be happy to show you. But if you have your sine and your cosine curves memorized, you don't need this little trick. By memorized, I mean the 4 quarter points and the amplitude. This is sine. Well, let's do cosine first. Amplitude's easy. It goes from 1 to -1. The fourth endpoint is 360 degrees. So where is it -1?
180.
Now since, okay. So the difference between yesterday and today would, if we got this, cosine of x equals 1, yesterday when our interval was 0 to 2 pi, we would have only had one answer. Today we would have 2 answers. Okay?
Okay.
And that's not because it's in degrees as opposed to radians. it's because they're using a bracket around 360 today, and they had parentheses around 2 pi yesterday, or day before yesterday. So that's the only difference. But it's not, it's significant in questions like this. And the sine curve, all you have to remember is that you start at 0, 0, and you go up. Okay? If you can remember that, there's no other way to draw it but that. Knowing that that's 2 pi, and that that's 1, and that's minus 1. Just figure out your quarter points, and all these key places are always at your quarter points. In other words, it hits 1 at pi over 2, comes back through there at pi, hits its low point at 3 pi over 2, and so forth. So that's actually pretty easy to memorize.
Yeah.
You can remember the 2 pi and the 1 and 1 and how it begins your n. And that's the best way to do the quadrangles, is to draw from the charts, the graphs that you know them to be. All right. What's that? Sine squared?
Yeah.
Of x equals 1/2. And notice this is not the same as this. Sine squared of x means sine x times sine of x. Sine of x squared means sine of x times x. So they're completely different. And it's worth knowing that. So what's my next step to solve here?
Square root both sides.
Okay, so sine x equals what?
Square 1/4.
Whenever you take the square root of both sides, what do you have to begin with?
Oh, plus or minus.
Square root of 1/2. Now, what is square root of 1/2?
Isn't it one? Is it 1/4?
Well, it's the square root of 1 over the square root of 2. It's not 1/4 because 1/4 times 1/4 is 1/16.
Yeah. Okay.
So it's got to be a fraction smaller than 1/2, but not 1/4. But if you do it this way, in other words, if you start under the premise that the square root of a over b is the square root of a over the square root of b, you can always break down these kind of problems. Okay? Well, this becomes 1 over square root of 2. Now it looks more familiar. What angle causes the sine to be that?
1 over 2. 45.
Okay. So that's one answer. What are others?
So we're looking for when sine is positive, right?
Positive or negative. That's
okay.
Why that's such a critical part of the answer.
So this is one of the ones that has 4 answers.
Right.
Okay, so it would be 45, then 115.
No, it's 180 minus 135 gives you 45.
Oh, I just did that math wrong. 135, then 225, and then 3, was it 20? No, 15.
Yeah. Here's what we're doing. This is a little tricky, so I'm going to write it out. In other words, in the fourth quadrant, we know that 3 minus some theta is equal to 45, right? In other words, when we're in the fourth quadrant, if we subtract the angle from 360, we'll get the equivalent first quadrant angle. So if you start with the first quadrant angle to begin with, and you're trying to figure out what theta is, then solve that algebraically. Move theta to the other side, bring the 45 over, and you have 315 like that. Okay, so you're basically solving the same exact thing that you've memorized for the second, third, and fourth quadrant in reverse, kind of. All right, let's see.
X equals cosine inverse 2.
Where's the cosine equal to 2?
That will be...
Look on your cosine graph. Draw the cosine graph out and then tell me where on that graph it's equal to 2.
Okay. Never.
Yeah. No solution. How about secant x? Where does that happen?
Secant x equals 2.
Remember, secant and cosecant are the opposite of sine and cosine. Sine and cosine are always in between -1 and +1. Secant and cosecant are always greater than +1 or less than -1.
Okay.
So this is a perfectly acceptable answer for secant. It couldn't be 1/2. So to solve this, the way I do it is, what if the secant of x is equal to 2, what's the cosine of x going to be equal to?
1. No. Yeah.
The reciprocal. And then go from there. In other words, do the conversion to one of your 3 primary trig functions and then solve it. That's just the way I do it. I don't know that that's necessarily the right way to think about it, but I find it easier to focus on 3 trig functions and kind of treat the other 3 as secondary trig functions. So where's cosine x equal to 1/2?
That's... Hold on, let me finish drawing the graph.
Okay. The graph, unfortunately, won't tell you this. The graph is great for quadrangles because you can quarter it up, but for these, the graph isn't specific enough. You need the 2 triangles.
Okay. Then it'd be 60 degrees.
And where else?
60 degrees and 300.
Okay. -14 cos x equals 7√2. Equals what?
That'll turn into √2 over -2.
Prefer to write it like that. Okay? Where does that happen?
-2 √2, 45 degrees.
Okay. Well, that's where a positive negative √2 over 2 would happen. We need the 2 quadrants where it's going to be negative.
Cosine's negative in the second and third.
Okay, so what are the equivalent to 45 degrees in the second?
135.
And in the third?
135 and 225.
Cosecant x equals minus 2.
Cosecant x minus 2. It'll end up being sine of negative 1/2. And then that happens. That happens x equals 210 and 330.
Good. Which one did we just do? 7?
Yeah, we're on 8.
Okay. So we have cosecant x equal minus 1.
That'll be sine positive 1? Or just negative 1 still?
Same thing. The reciprocals always maintain the same sign.
Okay.
That's why the unit circle really is not all students take calculus. It's all of course, then it wouldn't be a nice little something easily remembered. Okay, so where does this occur?
Net sine of x equals negative 1. This will be in the third and fourth quadrant, and it'll be...
It's a quadrangle. Always know that when you get 0 or 1 or negative 1, you're dealing with a quadrangle, multiple of 90. If you take your sine graph, chop it up into 4 parts, each of those 4 parts is a multiple of 90.
So it happens at 180 degrees.
No?
Sine? Oh, I'm looking at the wrong, yeah.
It's this point right there. What's that?
Yeah, it's 3 pi over 2.
270 here, just because if they give you the domain in degrees, I tend to think they want the answer back in degrees.
Okay.
Actually, last night, or the last time we were doing these, we probably should have been doing them in radians now that I think about it. I don't remember if we did or not. Now, for purposes of doing trig, I don't rationalize these. Because if you're looking at the 2 triangles that you have, you're not going to find it in rationalized form. You know what I'm saying?
Yeah.
So what angle is this?
That will be... that'll be 30 degrees, or no, hold on. It'll be...
Its first quadrant angle would be 30.
Yeah.
This is negative. So where is it? Negative?
Second and fourth quadrant.
Okay.
So it'll be 150 degrees.
Good.
And then it'll be 150 and 330.
Your math's better tonight. You're sharper.
I was just exhausted. I had done like 4 hours of AP Bio last night.
Ah. Okay. Okay. So what do we do with this?
Did we skip a problem?
Oh, maybe we did. Oh. Did we not do 10? Oh, we did 9. You're right. We did skip one. Here. Go back and do it. So cosecant x equals root 2 over 2.
So this happens, this will be sine x equals 2 over root 2, so then you'd have to rationalize that, so...
Hold on. What's wrong with that? Can you find a triangle where that would be true, and why can't that be true? Because that's a number less than minus 1. Even if it was positive, it would be greater than 1. Know that root 2 is about 1.4. So I've got 2 divided by 1.4. This whole thing is bigger than 1.
Okay.
Impossible.
Okay.
No
so that's, okay, so that is impossible.
solution. Must be why I accidentally skipped it. No. Not really, but... Alright, so how are we doing this one?
What
do you call this?
This is a quadratic.
Quadratic in sine x.
So we have to factor this.
You can have lots of quadratics. You can have quadratics in e to the x. You can have quadratics in x. Okay.
So both the signs will be positive.
Okay, what goes here and here for starters?
2 sine and sine. And then...
Don't have any choices. That better be it, or else
Yeah.
it's not factorable in the normal way. And don't put it beyond them to give you one that you'd have to use the quadratic on. And if you do, you do. And you can certainly use the quadratic on these in the same way you use the quadratic on polynomials. So, what do I got here? I got sine x equal what? Start with the easy one.
Sine x equals -1, and then sine x.
Where's that happen?
That happens at 3 pi over 2, so 270.
Or sine x equals -1/2.
And then that is pi over 2, so 90, or 180.
No. Always remember this. This is kind of my anchor, remembering what angle the sine is equal to 1/2. That's 30.
30.
Just lock that in. Sine of 30 degrees is 1/2. So which quadrant do we need to be in?
Third and fourth.
Okay, so what's the 30-degree angle in the third?
210.
And in the fourth?
330.
Okay. Obviously this one, same factoring, only we're in cosine instead of sine. So you end up with cosine x equal -1 or cosine x equal -1/2. You can take it from there, right?
Yeah.
Let's go on to harder ones. Okay, now we're back to that same interval, 0 to 2 pi with a parentheses around the 2 pi. So let's give our answers in radians. Okay, how do we do this?
Bring the cotangent over to the left side. And then do we factor out a cotangent here?
Uh-huh. What's left?
Cotan x minus 1.
Okay, now what?
And then
It's the first step. Don't forget that. Everybody forgets that one.
I don't.
In other words, either that's 0 or that's 0. So solve both of them.
Oh, okay. So cotangent x equals
Start there. Where does that
0.
happen? Where does that happen?
That's never right. Or
No, it happens. Remember what the cotangent curve looks like. So there's definitely a point where it crosses the x-axis. So tangent and cotangent's range is negative infinity to positive infinity. There aren't any values that they can't be. Well,
okay.
now I take that back. They both have asymptotes. They both have vertical asymptotes. No, that is true. Their range is definitely all reals. There's certain values that x cannot be. In other words, the x values are restricted by the vertical asymptote, but they definitely can be 0, both of them. The question is where. So, to answer that for cotangent, either you can memorize this curve. Do you happen to know? That's 0, obviously. What's this going to be?
Ooh.
The period on tangent and cotangent. It's just pi. So every pi, there is a vertical asymptote on the cotangent. And it looks like this. It's a repeat of that. Okay, so there's two places it's 0. What's that spot and what's that spot?
Pi over 2 and 3 pi over 2.
Okay, now let's solve the other one. Cotan x equals 1. So where is that equal to 1? And this one you can solve in the same way we did the cosecant and secant. In other words, let's convert it to a tan. Cotan x is equal to 1. What is tan x equal?
1.
Okay, where does that occur? This you can get off your triangles. You could get the cotan also, but I still prefer this technique.
45 degrees.
Uh-huh. And where else?
45 and 225?
Yeah, and in fact, if you're looking at the curve, you know that it's every 180 degrees. So I can instantly just add 180 to that answer. And I know I'm going to have positive the same spot on the second cycle of the curve. All right, let's do one last one here. Okay, this one's pretty good. This is a good one to end it on.
Oh, the email said we were an hour today. Are we not?
My reservation was only a half hour. I can do an
uh,
hour easily.
Hold on, let me see.
You want me to make it an hour and keep going?
Hold on, let me
I
ask
got
my,
nothing else afterwards, so for me it's not much difference. It's whatever you
yeah,
need.
let me ask my mom if it was supposed to be an hour or just a half hour.
Okay.
Half hour's fine.
Okay, let's just finish this problem because it's an interesting one.
Okay.
How am I going to do this one?
Should we convert sine cos to sine cosine?
Well, that won't solve the fundamental problem, is that we'll have two trig functions. In other words, whenever you have two trig functions that you can't turn into a single trig function, then you have a problem. If I have sine of x times cosine of x equals something, doesn't matter what, that's a hard problem to solve because I have two different trig functions. Okay, so the first step is to see if you can turn everything into the same thing. What can I turn the right side into?
Tangent.
1 over tangent.
Well, yeah, 1 over tangent.
Now what?
Should we move that over to the left side?
Multiply both sides by tan x, and you got tan squared x equals 1. Take the square root of both sides, and you got tan x equals plus or minus 1. That occurs at 45 degrees, 135 degrees, 225, and 315. Once you can get it in one trig function, it becomes real easy to solve it. So that's always the key. When you have like an equation, I'm sure that they have one here, like 17. 17 is in two different trig functions. So we got to convert it to the same trig function. Which one are we going to convert it to? Sine or cosine?
Cosine.
Right, because we can convert this. It's harder to convert that. All right. I will talk to you next time, Jackson.
All right. Thank you very much.
You're welcome. Bye-bye.